A Chinese open weights model has arrived that combines frontier coding, a 1 million token context window, and native multimodal input in a single system. That combination has never existed in open weights before. Minimax M3 launched on June 1, 2026, and it is difficult to ignore. Shanghai-based Minimax has been relatively overlooked in the West, but this release changes that. The specifications are genuinely impressive. 1 million token context, native text, image, and video input. Open weights promised within 10 days. The API is live now on OpenRouter and Minimax's own platform. Pricing at launch is 0.60 per million input tokens and 2.40 per million output. A promotional discount cuts that in half to roughly 0.30 input and 1.20 output. That is more than 15 times cheaper than Claude Opus 4.7. Your wallet will notice the difference. The technical heart is something called MSA, Minimax Sparse Attention. It is genuinely different from what most people are used to, and to understand why it matters, we need to talk about what attention actually is. In a standard transformer model, every token talks to every other token. When you have a sentence with 10 words, each word looks at all 10 words to decide what it means in context. When you scale that to 1 million tokens, you get 1 million times 1 million interactions. That is a trillion operations just for the attention step. This is called quadratic scaling. Double the context, quadruple the compute. That is why most models that advertise a million token window are actually mediocre at using the full length. The hardware simply cannot keep up. There is another piece called the KV cache. Think of it as the model's short-term memory. Every time the model processes a token, it stores two vectors for that token, a key and a value. On the next token, it looks up all previous keys to decide which previous values are relevant. For 1 million tokens, you are storing millions of these vectors in memory, and every new token has to search through all of them. Minimax Sparse Attention replaces this brute force approach with a 3-stage pipeline. Stage 1 is the index branch. Instead of throwing every token into the full attention calculation, MSA runs a lightweight scan across the incoming context. It builds a rough map of which chunks of text relate to which other chunks. This is like a librarian scanning the shelf and making a quick note of where each topic lives. Stage 2 is block selection. The index branch does not operate on individual tokens. It works on blocks of the KV cache, typically chunks of a few thousand tokens at a time. It scores each block by relevance to the current query, then picks only the top blocks. Everything else is skipped entirely. No computation, no memory bandwidth, nothing. Stage 3 is sparse attention. The model now runs the expensive attention calculation, but only on the selected blocks. Instead of 1 million tokens talking to 1 million tokens, you might have 1,000 tokens talking to 10,000 tokens. The compute drops from quadratic to roughly linear or subquadratic, depending on how many blocks are selected. Minimax says at 1 million tokens, M3 uses 1/20th the per token compute of their previous M2 generation. Prefill is more than 9 times faster. Decoding is more than 15 times faster. There is another important detail. MSA operates on uncompressed key-value data. DeepSeek's multi-head latent attention compresses the KV cache into a smaller latent space to save memory. That works well for short contexts, but at extreme lengths the compression loses precision. MSA keeps the full vectors, so it supposedly avoids that accuracy cliff. Independent verification is still pending, but the claim is significant. Think of it like this. Imagine you need one fact from a 3,000-page textbook. Dense attention is the student who rereads every single page, every single time they need anything. MSA is the student who flips to the index, finds the relevant chapters, and reads only those pages. The book is still on the shelf, but the student is not burning hours on every paragraph. Now the numbers, because that is what everyone is asking about. On StuffWeBench Pro, the real-world software engineering benchmark, M3 scored 59.0%. GPT 5.5 is at 58.6. Gemini 3.1 Pro is at 54.2. So M3 technically edges both. But Claude Opus 4.7 hits 64.3 and the freshly dropped Opus 4.8 is at 69.2. So M3 won the open weights bracket but did not touch the closed weight leader. Terminal Bench 2.1, which tests shell agent loops, M3 scores 66.0. GPT 5.5 is 78.2, so OpenAI still owns the terminal room. OS World Verified, the desktop computer use benchmark, M3 hits 70.0%. Claude Opus 4.8 is at 83.4. Again, Anthropic is sitting comfortably at the top of agentic GUI tasks. But then there is BrowseComp, the autonomous web search benchmark. M3 scored 83.5. Minimax claims that is higher than Opus 4.7. If that holds in independent testing, it means M3 is surprisingly strong at browser automation. And here's where it gets genuinely impressive. Minimax ran a 24-hour autonomous demo. They gave M3 a broken FP8 matrix multiplication kernel on NVIDIA Hopper GPUs, no reference implementation, just a task description and a benchmark script. M3 made 147 benchmark submissions across 1,959 tool calls. Over 6 landmark optimization rounds, it pushed hardware peak utilization from 7.6% to 71.3%. That is a 9.4 times speedup. Best solution dropped on submission 145. Most other models allegedly gave up before 30 submissions. M3 simply kept going. They also ran a 12-hour research replication. M3 reproduced core experiments from an ICLR 2025 outstanding paper, generating 18 commits and 23 experimental figures with zero human intervention. That is the kind of persistence you do not see every day. So what changes? For developers, the biggest shift is the open weights promise plus frontier coding in one package. You can theoretically download the weights, run them locally, and fine-tune without sending your codebase to a closed API. That is the ideal scenario. But check the license first. Minimax open weight releases often have commercial use conditions that require written authorization, so it might not be as open as true Apache 2. For researchers, the MSA architecture is the story. If sparse attention can genuinely deliver near-frontier performance at 1/20th the compute, the entire scaling debate shifts. It is no longer just about who bought the most GPUs. It is about who engineered the smartest index. The new focus is efficiency over brute force. For competitors, the price is a direct attack. 0.30 per million input tokens is not a typo. At that rate, you can run agentic workflows that make thousands of model calls per session without your finance team having an existential crisis. OpenAI and Anthropic are going to need to respond or risk getting their lunch eaten by a model that costs pocket change per million tokens. But we need to look at the caveats before you rush to OpenRouter and deploy this thing into production. Every single benchmark number I just quoted was vendor run on Minimax's own infrastructure. They used Claude Code as scaffolding for the SWE Bench Pro evaluations. Independent scores from Artificial Analysis and Ella Marina were still pending as of launch day. So these numbers carry trust me energy until third-party audits drop. The open weights have not actually shipped yet. Minimax committed to releasing them within 10 days. Until they are on Hugging Face, this is technically API only. There is also the geopolitical reality. China's 2017 National Intelligence Law requires Chinese companies to support and cooperate with intelligence work. That applies to every prompt processed through Minimax's API, regardless of where you are sitting. For regulated industries, that is a serious concern. If you are building healthcare or finance applications, read the compliance documents carefully before routing sensitive data through Shanghai. Also, the stock literally tanked 12% on launch day. Minimax shares surged 5% at open, then nosedived on heavy volume. Wall Street said hype in the morning, doubt by noon. Sometimes the market does a sanity check that the technology crowd ignores, and vendor benchmarks on coding tasks have a history of being gamed. StubSuite Bench is exploitable if the model saw enough GitHub issues during training. Minimax has not published training data details, so stay skeptical. At the end of the day, Minimax M3 is the most credible open weights challenger we have seen in 2026. It is not the best in the world yet. Opus 4.8 still wears the crown on pure capability, but M3 proves that open weights models can genuinely compete on coding, context, and multimodality at the same time while costing almost nothing. The closed labs are no longer the only players in this story. If you would like to hear and see the latest news about LLMs, then like and subscribe.